The question is, could you do an example on finding the second moment of inertia of a 2D section with a hole? This is the problem that I have selected here. We have a hollow rectangular tube with outer dimensions of 120 millimeters by 80 millimeters and a wall thickness of 8 millimeters. The hole is symmetrically placed inside the outer area, meaning that the center of the hole coincides with the center of the outer area. So there are two lines of symmetry for both the hole and the outer area, which are the vertical and horizontal lines passing through the center, right? Therefore, the center C is the centroid for both the hole and the outer area, and therefore C is the centroid of this hollow area. So using the principle of lines of symmetry, the task of finding the centroid for this section is trivially achieved. So here we'll focus on finding the second moment of inertia of this hollow section about one of the two axes that pass through the centroid, the x and y axes. Specifically, we'll try to find Ixx. Here we will calculate Ixx using the methodology we have established for a composite shape. Remember, the first step in this methodology is to develop a subdividing scheme, right? Our scheme here is fairly simple. We will take the area representing the solid part as the composite area, and that part is obtained by subtracting the whole from the outer area. If you recall, this is the formula for finding the second moment of inertia of a composite shape. So what are the terms we have on the right side here? The first term here, Ixi prime xi prime, is the second moment of inertia about the centroidal axis xi prime. Ai here is the area of the sub-area. Yi is the y distance between the global x-axis and the local xi prime axis. In this example, the global x-axis and the local xi prime axis coincide with each other for both the outer area and the hole. Therefore, the second term is 0 for both sub-areas. And on this basis, the sum simply expands into this. That is, Ixx of the composite area equals Ix prime x prime of the outer area minus Ix prime x prime of the inner area, which is the hole. I brought the formulas here for the second moment of inertia about the centroidal axis for a rectangle. Ixx is bh cubed over 12. So b in this formula is the dimension parallel to the axis x, right? And h is the dimension perpendicular to the axis x. I have chosen to use meter as my unit of choice for the linear dimension. So now, considering the outer area, the dimension parallel to the axis is 80 millimeters, which is 0.08 meters. The dimension perpendicular to the axis is 120 millimeters, which is 0.12 meters. So that's what I have over here, 0.08 times 0.12 cubed over 12. Now, considering the inner area, the dimension parallel to the axis would be 80 millimeters minus 2 times the wall thickness, which is 64 millimeters, or 0.064 meters. The dimension perpendicular to the axis would be 120 millimeters minus 2 times 8 millimeters, which is 104 millimeters, or 0.104 meters. So those are the numbers you see here. The units for Ixx would be meter to the power of 4. Simplifying these, we get this number for Ixx, 5.52 times 10 to the minus 6 meter to the power of 4.